Now that we've got an equation for the time-dependent Q on the capacitor, we can very easily find the current in this circuit. And well, if we've got Q, what is current? And it is time-dependent. It is changing as this capacitor gets more and more full. The current slows down more and more. How do you find I? How is it related to Q? Well, I is simply equal to dq dt. It's the rate of change of the charge, how fast charge goes by a point in per unit time. So we just got to take the derivative of this, and all I got to do is I'm gonna use this version of it right here, and I'm gonna go ahead and figure that out. What I'm gonna do is to take the derivative, I'm gonna multiply through. In other words, Q equals CE minus CE times this E to the negative t over RC, and then taking the derivative of that, dq dt, is just equal to the time derivative of this whole mess, CE minus CE e to the negative t over RC. And notice that this is just a constant, so that just goes to 0. So we're going to take the derivative of this equals d dt of CE e to the negative t over RC, which is CE remains our constant right there. And we still have this because the derivative of e to a function is just e to that same function, but we got to use the chain rule to take the derivative of what's up here, that thing right there. We got to take the derivative of that, and that's going to give us our correction factor of -1 over RC. So when we're all done with this, we have the current as a function of time is equal to CE negative over RC times e to the negative t over RC. And what do we have here? Whoops, there's a drop to negative right there. So this should still be negative there. There's negative. This is negative, and there we go. That will make that positive right here. So I get positive right there. And what I'm getting, notice that this C cancels this. What's E over R? I is equal to E over R, e to the negative t over RC, where E over R is just the initial current. I equals I max, the maximum current that's happening initially when you first close the switch, e to the negative t over RC. There we go. There's our final result.